Solving Quadratic Inequalities with Tutor. Here are some of the easier questions that you're likely to find on this topic. Quadratic inequalities are inequalities that involve a quadratic expression in the form of ax squared plus bx plus c. Solving them involves finding the range of values for x that satisfy the inequality. The steps to solving quadratic inequalities include, firstly, ensuring the quadratic expression is on one side of the inequality symbol and 0 is on the other side, as shown by this example. Secondly, we factorize the quadratic expression, so looking for factors that multiply to give me positive 20 but add to give me negative 9, meaning my double brackets would be x minus 5 and x minus 4, which is less than 0. Thirdly, we need to find the critical points. This is the roots of the quadratic when equal to 0. If x minus 5 was equal to 0, x would be equal to 5. And if x minus 4 was equal to 0, then x would be equal to 4. To determine the solution, it will be easier if we have a sketch of the graph, so that will be the next step. The quadratic has a positive x squared term and has roots 4 and 5, so we'll look something similar to this. Use dashed or dotted vertical lines going through the critical points of 4 and 5. This will now help us to visualize the regions where the inequality holds true. Since we're looking for when it's less than 0, the x-axis is defined as y equals 0. So if my quadratic is less than 0, it would be when my solutions are below the x-axis. So looking below the x-axis, you can see the solutions for my quadratic or my curved part fall in between the 4 and the 5. Therefore, the region where the inequality is satisfied and when x squared minus 9x plus 20 is less than 0 will be my solutions for x that are in between 4 and 5. So x is greater than 4 but less than 5. We can write this as one compound inequality since the region is represented by one section. On to the next question. Factorizing my quadratic, numbers that multiply to give me negative 12 but add to give me positive 1, x plus 4 and x minus 3 is greater than or equal to 0. Find my critical points or my roots, which would be when x is equal to negative 4 and x is equal to 3. Sketch the graph using my roots of negative 4 and 3. Draw vertical dotted lines going through the critical points. Since I'm looking for when my quadratic is greater than or equal to 0, this will be my solutions for my quadratic which are above the x-axis, and the solutions are represented by this part of the curve to the right hand side of 3, and this part of the curve which is to the left hand side of negative 4. Therefore, the regions where the inequality is satisfied is represented by two separate regions, when x is less than, and since the inequality symbol is inclusive, when x is less than or equal to negative 4, or when x is greater than or equal to 3. On to the intermediate questions, with a slight increase in difficulty. Firstly, we'll need to factorize the quadratic expression. Since the coefficient of x squared is greater than 1, I'll need to use the AC method to help me do this. Multiplying the coefficient of x squared a by the constant c gives me negative 15. I need to rewrite the quadratic expression, splitting the bx term into two terms where the coefficients multiply to give me negative 15 but add to give me positive 14. So 5x squared plus 15x minus 1x minus 3 is greater than or equal to 0. Split the quadratic expression in half and factorize the left hand side and the right hand side into single brackets. I'll be able to take a factor of 5x from 5x squared and 15x. 5x will need to be multiplied by x plus 3 to give me 5x squared plus 15x. Assuming we've done this correctly, the bracket that we have on the left hand side should be the same as the bracket on the right hand side, and this will make it easier to then factorize, since I just need to multiply by negative 1 to give me negative 1x and negative 3 on the line above. So one of my factorized brackets is x plus 3, and the other one is made up of 5x minus 1. And I'm looking to solve when these are greater than or equal to 0. Find the critical values. X is equal to negative 3 and x is equal to 1 over 5. Sketch the graph using my roots negative 3 and positive 1/5. I'm looking to solve when my quadratic expression is greater than or equal to 0. This will be above the x-axis, and my solutions for my quadratic when above the x-axis are to the right-hand side of 1/5 and the left-hand side of -3. Therefore, my solutions would be when x is less than or equal to -3, or when x is greater than or equal to 1/5. On to the second question. We need to solve, and we have a quadratic expression which has a negative x squared term at the beginning. We just need to be careful when factorising, looking for numbers that multiply to give me -12, add to give me -7. I also need to consider the fact that I have a negative x squared term, which can only be achieved by having x in one of the brackets and negative x in the other. Numbers that multiply to give me 12 and add to give me 7 will be 3 and 4. And I just need to make sure that I have these the right way round so that when I multiply out, I end up with -7x in the middle when collecting like terms. You can always expand to check your answer. X multiplied by -x will give me -x squared. 3 multiplied by -x will be -3x. X multiplied by -4 will be -4x. And -4 multiplied by +3 will give me -12. We can see that these simplify to give me the -7x in the middle, along with the -x squared and the -12 that I was looking for. My critical values will be when x is equal to -3. For this one, -x would be equal to +4, which means that x is equal to -4. Sketch the graph. This time, I need to be mindful of the -x squared. Flips the quadratic in the x-axis, meaning it will look more like this, with my roots of -4 and -3. Draw vertical dashed lines going through the critical values. And since I'm looking for when my quadratic expression is less than 0, that would be below the x-axis, where the solutions for my quadratic fall to the left-hand side of -4 and to the right-hand side of -3, represented by these shaded regions, where x is less than -4 or x is greater than -3. The advanced question is one of the trickier questions that you're likely to find on this topic. Find the set of values for which 8x minus 7 is less than 5x plus 5, and at the same time 2x squared minus 5x minus 3 is greater than 0. We'll start by solving each of these separately. So starting with this inequality, we can start by subtracting the smaller amount of letters from both sides. 8x minus 5x is 3x, minus 7 is less than 5. Adding 7 to both sides gives me 3x is less than 12. And finally, dividing through by 3 gives me x is less than 4. Moving on to the quadratic inequality, and using the AC method, since my coefficient of x squared is greater than 1, a multiplied by c gives me -6. Factors that multiply to give me -6 but add to give me the -5 in the middle will be -6 and +1. Splitting the quadratic expression in half and factorising into two single brackets, I can take 2x as a factor from 2x squared and -6x, leaving me with x minus 3 inside the bracket. That means this will also be x minus 3, which means the factor must be 1, leaving me with my final double brackets of x minus 3 multiplied by 2x plus 1. Find the roots or the critical values. X would be equal to +3 and -1/2. Sketch the graph using my roots of -1/2 and 3, or vertical dashed lines going through the critical values. And I'm looking for when my quadratic expression is greater than 0. This would be above the x-axis. Solutions from my quadratic fall to the left-hand side of -1/2 and to the right-hand side of +3, represented by these shaded regions. Therefore, x is less than -1/2 or x is greater than 3, since it needs to satisfy both of these inequalities at the same time. A number line might be quite useful to visualize what's happening here. So starting with this inequality on the number line, this would be an open circle above 4, and values for x are less than 4, so would be an arrow going to the left-hand side. And then plotting this inequality on a number line, I'll do this just above the one that I've done already. X is less than -1/2, or, so on the same line, x is greater than 3, and I'm looking for the regions or the set of values that satisfy both of these at the same time. So will be where the number lines overlap between the two, shown by this region here and this region here, which would be when x is less than -1/2, or when x is greater than 3 but less than 4. Here's a question that I've completed earlier. It appears as though I've made some mistakes. Pause the video and see if you can spot what they are before writing some corrections in the comments below.
Thanks for watching. If you found that video useful, don't forget to hit the like button and leave a comment. If you're struggling with topics or finding maths difficult, subscribe and turn on notifications to receive regular updates about new video tutorials and other useful content. You can visit and follow all of my socials by clicking the links in the description below.